Hello everyone, welcome back to Prakriya Educations. I am Mallikarjuna. In this module, we shall learn to find the inverse of the function f using 1-1 and on-to method. Look at the first problem. Let f be the function defined from R to R given by f of x is equal to 4x plus 3. We need to show that f is invertible and also find the inverse of the function f. Now starting with 1-1 and onto functions, the first one, that is for the 1-1 function, you remember that for 1-1 function we need two elements. Now let x1 x2 belongs to the real number set R, which is in the domain. Now if f of x1 is equal to f of x2, f of x1 is 4x1 plus 3 is equal to 4x2 plus 3. 3 gets cancelled, you are left with 4x1 is equal to 4x2. 4 gets cancelled and hence you are left with x1 is equal to x2. Starting with f of x1 is equal to f of x2, we are end up with x1 is equal to x2 and hence we can conclude that f is 1-1 function. Now the second one, that is for the onto function, remember the definition, the range of the function f should be equal to the codomain of the function f. Consider the elements first. The element x is chosen from the real number set, which is from the domain, and let y be an element from the codomain of set R again. Then f of x is equal to y. Now f of x is being given as 4x plus 3 is equal to y. Now we need to write x in terms of y and hence solving for that we get x is equal to y minus 3 divided by 4. In the domain we are having the set of real numbers. In the real numbers we do have these type of elements and this belongs to the real number set which is in the domain, and hence what you can conclude, for every y which belongs to the codomain R, there exists some element x which belongs to the domain R such that f of x is equal to y, and hence we can conclude that therefore f is onto function. And since f is 1-1 and as well as onto, we can now conclude that f is bijective function. As per the definition, if the function f is a bijective function, we can conclude that f is an invertible function. Now, in order to find the inverse of f, we have another extra step. The third step, that is to find the inverse of f. Consider two elements, that is x from R, which is from the domain, and y from R again, which is the codomain, such that f of x is equal to y. Then start with this equation, that is f of x is equal to y. F of x is given by 4x plus 3 which is equal to y. The same steps as you have followed here. Then we get x is equal to y minus 3 which is divided by 4. And this x is nothing but f inverse of y as per the definition, which is given by y minus 3 divided by 4. This is the inverse element of the function f, and hence you can define the function f as f inverse is a function which is defined from, just reverse these two sets, that is R to R again, given by f inverse of y is equal to y minus 3 divided by 4. and hence we have used 1 1 and onto method to prove that the function f is invertible function, and in the last step we have found the inverse of the function f and is given by this. Look at the next problem. Consider the function f from R plus the set of all positive real numbers to this interval given by f of x is equal to x square plus 4. We need to show that the function f is invertible with f inverse, and it is given by root of y minus 4. Again using 1 1 and onto method, starting with 1 1 function. Consider two elements. Let x1, x2 belongs to the domain R plus. Now if f of x1 is equal to f of x2, this implies that according to the definition x1 square plus 4 is equal to x2 square plus 4. 4 gets cancelled and will be left with x1 square is equal to x2 square. x1 is equal to plus or minus root of x2 square, and do remember we are having only positive real numbers and hence you can neglect the minus sign. Then we get x1 is equal to x2, and hence we can conclude that f is 1 1 function. Now going for the second one, that is for the onto function. Now choose the elements. Let x be an element from R plus, that is from the domain, and y be an element from the interval 4 to infinity, which is the codomain, such that f of x is equal to y. Now f of x is nothing but x square plus 4, which is equal to y. Now you need to express x in terms of y. Solving this, we get x is equal to root of y minus 4. And therefore we can now conclude that, and hence we can now conclude that for all y which belongs to 4, infinity, there exists some x which belongs to the positive real numbers, such that f of x is equal to y. And you know that the set of real numbers has been given in the domain, and therefore every element of this kind will be in the set of real numbers, that is positive real numbers, and hence this condition has been verified, and therefore you can now conclude that f is an onto function. And therefore you can also conclude that f is invertible function. Therefore half of the problem is complete. We have already proved that f is invertible function. Now to check what is the inverse of f, to find that we can choose two elements. Let x belong to the domain and y belong to the codomain, such that f of x is equal to y. Now starting with this one, this equation, that is f of x is equal to y. F of x is nothing but x square plus 4, which is equal to y. So now applying the same steps which we have done in the onto function, we get x is equal to root of y minus 4, and this implies that x is nothing but f inverse of y by the definition, which is equal to root of y minus 4. And therefore you can now define the function f inverse as, define f inverse from, just reverse these two sets, we get 4 to infinity to R plus, given by f inverse of y is equal to root of y minus 4. Look at the next problem. Show that f function which is defined from interval minus 1 to 1 to the set of real numbers given by f of x is equal to x by x plus 2 is a 1 1 function, and we also have to find the inverse of this function. Now again starting with the 1 1 function, consider two elements. Let x1, x2 belongs to the domain, that is minus 1 to 1, which is the domain set, then if f of x1 is equal to f of x2, simplifying the above step, now you can cancel out this, we remain with 2x1 is equal to 2x2, again cancelling out, we get x1 is equal to x2 as required, and therefore we can conclude that f is 1 function. Now we shall find the inverse of the function f. The inverse of function f can be found, let x be an element from the domain and y be an element from the range of the function f, such that f of x is equal to y. Now then we shall start with f of x is equal to y. F of x is given by, now we need to write x in terms of y, and hence simplifying this we get x is equal to 2y by 1 minus y. And therefore we can now conclude that f inverse defined from the range of f to the interval is given by the function f inverse of y, which is equal to 2y by 1 minus y. Look at the next problem. Consider the function f from r plus 2, the interval minus 5 to infinity, given by f of x is equal to 9x square plus 6x minus 5. Show that f is invertible with f inverse as given. Solving this, in the first step we need to prove that the function is a 1 function, starting with taking two elements x1 and x2 from the domain and consider f of x1 is equal to f of x2. We need to now substitute x1 and x2 in the place of x given in the expression f of x. Solving that, we get 9x1 square minus 9x2 square plus 6x1 minus 6x2, while minus 5 cancels out both the sides. Now we can take out 9 common in the first two terms and 6 common from the next two terms, and using the formula a square minus b square, replacing that by a minus b into a plus b, we get the modified expression as 9 into x1 minus x2 into x1 plus x2 plus 6 into x1 minus x2 is equal to 0. You can now take out x1 minus x2 common from the expression, and now equating x1 minus x2 is equal to 0 or 9 into x1 plus x2 plus 6 is equal to 0. The second factor is impossible, and hence we can conclude that x1 is equal to x2, and therefore we can conclude the function f is a 1 function. Now going for the second step, that is to prove whether the function is onto function. Given that the function f from r plus 2 minus 5 to infinity and f of x as given, replacing f of x by y and going on solving it using the quadratic formula method, we need to now find the value of x in terms of y, and we get the value of x as x is equal to plus root of y plus 6 minus 1 whole divided by 3, and we shall name it as g of y, which belongs to the domain r plus, and hence we can now conclude that the function given is an onto function. And hence, since the function is a bijective function, we can conclude that the given function is invertible and f inverse exists. And the function f inverse is defined from minus 5 to infinity to r plus, with f inverse of y is equal to root of y plus 6 minus 1 whole divided by 3. Hope you enjoyed the video. Please don't forget to like, share and subscribe. Thank you.